Hey, what's going on? My name is Rob Blossom, and today we're going to be building a first-person controller using the new input system in Unity, just like the one you see on screen right now. Okay, let's get into it. Alright, so you can see I have a basic scene set up here in Unity. It's just a little room I set up with ProBuilder, as well as a sphere here for testing our collisions and everything work fine. We've got a camera here, it's just the main camera. I've added nothing to it, but you may see some post-processing stuff here from the universal render pipeline. That's it really. The first thing to do, of course, is to, if you haven't already, jump in and enable preview packages in Window Package Manager. And you're going to let that load and look for the input system. Go ahead and click install. Click yes if it asks you to enable the input backends, and close your package manager, go into project settings, go over to player, go to other settings, and scroll down to where your active input handling is, and make sure it's either on both or in input system package, and then go ahead and restart Unity. Okay, now that we're back in Unity, we should have the new input system ready to use. So we're going to start by creating a scriptable object to store our input actions. I've made a previous tutorial where I have used the generator window to create a C# file automatically, and I've actually fallen out of favor with that method, which is kind of why I decided to make this video, to sort of put that in the dirt and show a different method of doing things. So we're going to call this one input data. If you don't know, a scriptable object stores data for the most part. That's what we use it to store, and it can be independent, or it has to be independent of a game object. I recommend, if you're not familiar with them, to go and watch my video about scriptable objects, or someone else's. Totally watch mine though, it's the best. And come back. So instead of inheriting from auto behavior, we're going to inherit from a scriptable object. And I'll just pop this under a namespace since I should be teaching you good practices. So I'll throw it under tutorial, and we're going to define a public input action. We can find input action and all of the other input system stuff under the namespace Unity engine.inputsystem. Or sorry, that's Unity editor, Unity engine.inputsystem. And you can see we now have access to input action. So in input action, if you haven't seen the other or any other input system videos, or you haven't read the documentation yet, I highly recommend you do. An input action simply defines a key, and it allows us to subscribe to pretty much every possible event related to that key, as well as change almost every possible setting related to that key. So it's basically a binding, and it's called an action. So for this one, we're going to call this one movement action. And we're going to create another one called look action. Since this is our first person controller, we'll want our mouse delta and our movement up and down. And that's it for the scriptable object. The only other thing is that we're going to create an asset menu definition, which will allow it to pop up in our context menu when we right click. So let's go ahead and minimize out of this. We'll let that compile. And if we right click and click create, we'll see input data up the top here. I'm just going to call it input data. And we can already see that we have our movement and look actions right here. Okay, so what I'm going to do is click on movement action and add a 2D vector composite. So this will be a 2D vector defined by a particular set of bindings. So usually it's up, down, left, right, which you can see here. So I'm just going to call this keyboard, and you can add as many bindings as you like, keep in mind. You can add absolutely as many as you like. You could add more for the arrow keys. Just click on plus and click 2D vector composite. You could also add an axis for the Xbox controller, and they would all work all at once. So that's a really good way to support multiple controllers, like right out of the bat. Like you don't have to do any work to support multiple controllers, which is something that my old way of doing things didn't really facilitate. So just double click on these bindings and we get the path. We can click listen and listen for the input, or we can scroll through and find the input here. I prefer to just listen since it's a lot faster when you're doing keyboard stuff, and also a lot faster for joystick stuff. So you can see I'm just assigning A to left, D to right, W to up, and S to down. Apologies if I'm going a little fast here. I've done this a million times before, so maybe I should slow down a bit, but I also don't want to bore you since it's pretty simple stuff. And for the look action, we're going to take the mouse delta. Now, if you're not familiar with what a delta is, it's basically describing the change between two values, to put it very, very simply. So we'll add in a binding, a single binding, since the delta is a single binding. And you can either take pointer or mouse. I believe pointer is more generic, so it may work, for example, a pen touch, or it may work for a touchscreen on a mobile device. So I like to go as generic as possible, so we're just going to use pointer and use the delta position. Okay, that's it. Our inputs are binded, and you can see anytime we want to change a binding or add a binding, all we have to do is come over here and click add. It's that simple. So now that that's stored in our scriptable object, let's go ahead and use it. I'm going to create a C# script in here, and I'm going to call this camera movement. Now for our first person controller, since we're using a rigid body, we would probably not want to move the entire player's rotation up like this. We just want to move the camera up like this, but rotate the player side to side. So our camera script is going to go on our camera to move the camera up and down, tilt it, or pitch it up and down. And we're going to have a separate script for moving the player forward and backwards, left and right, so strafing and moving the player, as well as looking side to side, which will rotate the entire player. Okay, so opening up our camera script, let's drag our camera script onto there, lest we forget, and open it up. Don't forget to use a namespace. Okay, so I don't have auto formatting, so I'm just going to fix that real quick, since I am very not used to C# bracket style, so I want it to fix that for me. There we go. Okay, inside our camera movement script, the first thing we should do is take a reference to that data. So I'm going to create a header called data so that it shows up nicely in our editor. And then I'm going to create a serialized field, which will be private, and we'll take input data in, and we'll call this input data. And another thing I'm going to do real quick is just lock the cursor preemptively. So we can call cursor.lockState equals cursor.lockMode.locked, and cursor.visible equals false. Okay, and that'll just lock our cursor. So if we go back into the editor now, and just for handiness, I'm going to move this, come on, there we go, up here. So we can see that we can select the input data now. Sorry, that was on my other monitor, like so. So in terms of the input data, this will actually just reference our scriptable object. And if you're wondering how this works in terms of building our game, anything that references a scriptable object will cause that scriptable object to exist. It's almost like a really complicated version of a smart pointer, in the sense that anything pointing to a scriptable object will validate its existence within Unity's internal API and cause that scriptable object to be built in and created. If nothing in a scene is referencing a scriptable object, it might as well not exist. It may exist, but it probably won't. So that's an interesting point about scriptable objects. So jumping into our script here, you see that we're setting the cursor to locked, and we're also setting it to invisible. So if we play our game, hopefully we should have a locked and invisible cursor. Yes, we do. I'm moving the mouse and nothing is happening. So that's going to be useful for actually, using our first-person controller. Okay, so the next thing we want to do is actually use our inputs. Now, I'm going to intentionally make a mistake that's very easy to make here so that I can show you how to fix it if you ever get stuck. So in fixed update, I'm going to start by reading in the value from the look action. So we're going to take a vector 2. Remember, our look is a delta, right? So it's a delta for the x-axis and the y-axis for the mouse. And obviously that can be read into a vector 2, or at least intuitively it can be read in as a vector 2. So we're going to call input data, which is our reference to our scriptable object. We're going to take the look action, input action, which is defined as a public field. And then we're going to take the read value method and call it. Now, read value is interesting because it takes a, it's a generic method. So it takes a type, and obviously we want to read it into a vector 2. So this will tell it to read the value into a vector 2, and it will thus return a vector 2. If you call this float, it will return a float rather than a vector 2. And it's a method, so we'll call it. So it's a generic method. And then what we're going to do is just debug.log look to make sure that it's working before we actually write any code. Now, this won't work. Like I said, I'm going to intentionally make a mistake so that I can show you how to fix it. Oh no, it says 0, 0 on our console. Even though I am frantically moving the mouse, nothing is happening. So this is a very common mistake that I tend to make, and I think it's very, very easy to make. All we need to do is go into our scriptable object and add in the onEnable. Sorry, that may as well remain private. OnEnable. So scriptable objects do have an onEnable just like a monobehavior, but when that onEnable happens is really up to Unity. Like I said, it depends on whether it's being referenced or not. And we need to call lookAction.enable, and that will actually enable the lookAction to read values in. And you might guess that there's probably a time where we'll want to disable these. Now, you could also make these public methods and then call those methods from within onEnable and disable, and that would allow you to disable the input whenever you want. This is super useful for disabling all of the player's actions when the game is paused, for example. That is a very good way to do this. So if you just publicize a method here called stop player movement and start player movement and call enable and disable, this is such an easy way to just completely destroy all input from your player without having to do any crazy setup or anything. So all we're going to do is call movementAction.disable and lookAction.disable. Okay, so when we jump back into the game, we're going to hit play, and as you will see, we now have a bunch of numbers coming out in our console according to the mouse delta. So if it's completely still, I let go of the mouse, it's 0, 0. If I move it up, we get the delta in the up axis. I don't need to teach you this stuff, it's pretty simple. So let's go back to our camera movement script and let's write some basic code to move our camera up and down. So for that, we're going to start by taking in a private float for the pitch. And we do this because we want to have a consistent reference to what our current pitch is so that we can clamp it between 90 and negative 90 degrees. So what I mean by that is we're going to store a value as to how much pitch we have applied to the Euler angles of the transform. So just pretend this is the player. If we're at 90 degrees, we're up here. And if we're at negative 90, we're down here. We want to keep a consistent reference to that so we can clamp it between those values. Otherwise, we'd be able to do a full 360 flip, which would probably break our movement since we'd be moving in the opposite direction and lock our movement. Now, you may not want to do that depending on what kind of game you're making. If you're making a Dusk style game, of course, you might want to have bat flipping. But I'm just going to clamp the movement since that's the way I like to do it. So what we're going to do is set the pitch, incrementing it by the y look vector, so that's our delta in the y-axis, and we're going to multiply it by time.delta time. Now keep in mind, I'm doing this in fixed update just to keep it in sync with our player's movement when we write that. Delta time actually does respond to fixed update. It's something that a few people don't know in the forums and on Reddit and stuff that I see. There is also fixed delta time, but delta time actually changes the value that it returns, even though this actually lies to you a bit. It says that it returns the time in seconds since the last frame, but if you look at the documentation for time.delta time, it actually tells you inside a fixed update it returns fixed delta time. So this does work. Then we're going to set pitch equal to mathf.clamp, and just like I said before, we're going to take the pitch and clamp it between negative 90 and 90 degrees. So what are degrees? Well, they're Euler angles in our case, so we're going to take vector 3 Euler equals transform.Euler angles. And that way we can then reassign it to our player after we set the x to our pitch and reassign. So all we're doing is basically keeping a track of the pitch. I'm going to initialize this to 0f, even though it will automatically, just to make it nice and explicit. So we're going to take this 0f, and then on the first fixed update, we're going to read in the look value. Let's say it's 0. So we're going to do 0 plus 0 multiplied by time.delta time, which is, of course, 0. Then we will clamp the pitch between negative 90 and 90, which is 0. And then Euler angles pitch, x will be set to 0 and then reassigned. When we first move the mouse, it will increment that angle, but keep it between negative 90 and 90. So when we start the game, you'll see that we're looking at 0, and now we can move our mouse up and down. But oh no, it's inverted. Damn, what do? Do we go in and write some code that negates it depending on whether it's inverted or not? Nah, it's a lot easier than that. I'm going to open up our scriptable object for input data, and I'm going to show you what a processor is. If I remember where I actually put it. Oh, it's just here, isn't it? There we go. So let's go in and add a processor. So if we double click our delta here, we can see we have a processor setting. And if we hit add to that, you can see we can add scale and we can add inversion. We'll get to scale in a second. So let's add some inversion. Now we only want to invert the y-axis for now. So we'll uncheck invert x and only invert y on the vector 2 of the delta. And if we go ahead and play this again, oh, hey, look, now when I move my mouse up and down, nice and simple. So what, that was like, 2 minutes, a couple lines of code, and we've already created up and down movement. Nice and easy. Let's get on to our code for the player. So in order to create a player, we're going to start with an empty game object. Actually, I'll tell you what, I'll make it easier. I'll make a capsule, and that will have a rigid body. Now, there's a bit of tweaking we're going to do to the rigid body in the future, but for now, we'll just leave it at its default settings, but we will check the constraints. So we'll want to constrain the rigid body, or all of its rotation, and we'll also freeze the rigid body on its Y position. Since I'm not going to make a tutorial on jumping, it's a little bit out of scope, I think. I'm also going to turn on interpolation and set the collision detection to continuous dynamic. This is just to give a little bit smoother in terms of movement and reduce the chance that we miss a collision. Okay, the next thing to do is to create a C# script called body movement, or at least if you want to call it body movement. And we're also going to drag the camera inside of that capsule to let it move along with the capsule. So let's drag it inside the capsule. And let's go ahead and move the capsule to where we are now. I hit Control-Shift-F to do that. I'm going to fix its rotation, just zero these out. And I'm also going to go to the camera and adjust that to be at 0, 0, 0 relative to that. And then we'll drag it up a bit. All right, so there's our basic capsule here for our player. Just going to get the camera nice and snug there. And we'll also drag our body movement script onto our, actually I'll put it below this mesh render, or I'll put it all the way at the top. Put our body movement script onto our player. And of course, I will also rename this to player and tag him as the player, not that we'll need it. Okay, let's start with a couple of variables. So we'll start with a header called movement, and we'll add a public float called move speed. I'm going to default that to 3 floating point, and we'll also create a maximum velocity for our character, and you'll see why this is important in the future. We'll also need access to that input data. So like I do before, I'm going to create a serialized field for the input data. And we'll need a reference to our rigid body. In the awake method, we're going to call getComponent and ask for the rigid body and assign it to that body property. Now inside our fixed update, let's grab that movement value. So we're going to call vector2. So again, remember, we're using a vector2 for the movement. It's W and S, which is up and down on the y-axis, and left and right on the x-axis. Keep that in mind. And I'm just going to call that movement, and set that equal to input data dot movement action dot read value. You guessed it, vector2. Finish it off. And for now, once again, let's debug.log movement. I'll just make sure I remove the debug.log call here. Yep, so that we don't get spammed with 2 conflicting pieces of information. Go into the console. Don't worry about those warnings there. That's just what happens when you have a serialized field that is private. Obviously, C# has no way of knowing that you're actually going to assign to it. But we just assigned the input data in the relevant field for the body movement script. Okay, so okay, you have to tell me if I'm going crazy, but did I not just rename that to player like 4 times and it renamed itself back to capsule? Or did I not hit enter or something? Anyway, I guess it doesn't matter. Let's play the game. And you can see we're getting 0 out in the console. And let's hit W, and you can see we're getting 1, -1, -1, 1. Perfect. So you know we're getting the right input. Another interesting thing is that this vector can be normalized. So if we hit both W and D at the same time, you'll see we're getting 0.7, and that's because that vector is normalized. I believe there is a way to solve that, and if you don't know what normalizing is, go have a look at the math for linear algebra and normalizing a vector. But in short, it's taking the magnitude or the length of the line and clamping it to a unit vector. That is why, well, technically, two inputs, W and D, combined together, which is 1 and 1 on the x and y axis, the magnitude of that vector would be the square root of 2, which is about 1.4. It's a irrational number. I'm pretty bad at math. I'm pretty sure can't be represented as a fraction. Point is, it's longer than 1, which is the unit vector, or sorry, the magnitude of a vector of 1, 0 or 0, 1. A magnitude of a vector 1, 1 is 1.4, the square root of 2, which is Pythagorean stuff. So you'd actually move faster on the diagonal axis than you would up or to the right or left. So you'd move faster going this way than you would up or left and right. And you can fix that by simply normalizing the vector of the W and D, turning it into, the up and down axis, turning it into a unit vector, clamping its magnitude to 1. And it is automatically being normalized. So that is something to look out for if you're doing this. You need to be aware that it is automatically normalizing your vector. And I believe that can be fixed by opening this up. Yep, you can see there's a normalized check. Sweet. Okay, so now that we've gotten that out of the way, let's go ahead and write some code to move the player. You may be familiar with the add relative force and add force functions provided to us, or methods provided to us by the rigid body. We're going to want relative force since we're going to want to move them on their local axis relative to where they're looking, rather than on the world axis. So when we press W, we don't just want to go up on the z-axis on the world, we want to go up on our local z-axis because we want to go forward relative to where we're facing. So we'll use relative force. Let's create a new vector 3 and pass in the movement x. But for the y, I'm going to say 0 float, and for the z, I'm going to use the y-axis of the movement. Now, I'm sure you know why I do this, but it's pretty simple. The y-axis is our up and down movement, and in 3D space, that actually translates to forward and backwards movement, which is on the z-axis. So we're translating 2D information to 3D information here, since the vector that we're getting from our input, WASD, is just 2D. So we're using the y-axis in the z field here. Don't get cut off by that. We're going to multiply that by our movement speed, and we're going to use force mode.velocity change. Now, how you actually do the force here is up to you. I would definitely read through the different force modes, but velocity change is going to ignore the mass of our rigid body and add an instant velocity to it. So this is pretty good for me, at least for first-person shooters and stuff like that, because I like really snappy movement. I like the movement to be very instant, getting to top speed, and very quick to drop as well, and that's what our relative force gives us. Now, this isn't all, of course. There are going to be problems, particularly with our movement speed. So let's go ahead and play the game now. And you will see that we can indeed move forward, backwards, left, and right. Awesome. But there is a problem. Actually, this can be better illustrated by making this a lot bigger. Play the game again. We have this handy little info tab in the rigid body. So I'll hit escape to free my cursor, go to info, and have a look at our velocity here right in this field. It never stops. You'll notice it never stops getting higher. It just keeps going up and up and up. So what we would do is we would infinitely get faster, faster and faster and faster and faster forever. And that is obviously not what we want. We want to clamp it. So there's a very easy way to do this. I will just point out that when we're moving forward, it's in positive. So the z is in the positive direction. And if we're going backwards, it's negative. Pretty obvious, but just something to point out again. So a quick way to solve this is by using our maximum velocity float. So that's why I added this. So what we're going to do here is we're going to call mathf.abs, and we're going to take in our velocity on the x-axis. So abs is the absolute function, and it will change any negative value to its corresponding positive value. So if we have a velocity of negative 30 in the x-axis, it will change it to just 30. It will return 30 is what I mean. And that's very useful because we get an absolute velocity. We have a velocity of absolutely 30. It doesn't matter if we're going forward or backwards. Again, this is something you may want to tweak depending on your game. You may want your backward velocity to be slower than your forward velocity, in which case you would simply check if the velocity is less than 0, in which case you would change the threshold for which you compare this to. I think you can get that. So we'll say that's less than the maximum velocity, and on the condition that the absolute value of our velocity on the z-axis, so this is our forward and backward axis, So body.velocity.z is also less than or equal to our maximum velocity. Again, if you wanted your strafe speed to be slower, you could simply add in maximum strafe velocity and set that to a lower value. So now we're only adding any force on the condition that we are not at this maximum velocity already. And if I go ahead and run the game now, let's just double check that our movement speed and max velocity properties are set properly. Much better. Now we're going at a constant velocity, and that's a problem we will fix in a second. If I look at the info tab here, you will see that we get to -12 and we never go any higher than it. We get to 12 and we never go any higher than it. So it's not an exact solution. You will have to play with a lot of values, and we'll notice one problem is when I let go of the key, I slide. I really slide a lot. So how can we fix the sliding issue? First thing we're going to do to fix the sliding issue is we're going to increase the drag to about a value of 6. Now this totally is up to you. You need to play around with this properly, of course. But if we increase the drag to 6, immediately we'll see that I don't slide anymore. I have much finer grain control. And again, we can prove this by going into the info tab, and you'll see that our velocity, although it is actually going kind of crazy, that's weird. But anyway, we'll see our velocity gets up to about 10, and then it drops back to 0. And then we get up to about 10, and then drops back to 0. Cool. So that fixes that problem. The only other thing you may want to do is just play around with your move and max velocity until you get that right. But now that we've fixed that, we're going to jump into our fixed update and add in some code for our look input. So you'll be glad to hear our look input is a very simple function. We're going to take a vector2 for our look input. Actually, I might as well just call this look. We'll take our input data look action again, read value, vector2, and for this, what we're going to do is call body.addTorque. So add torque is adding a rotational force rather than a positional force. So let's add torque, and we're going to create a new vector3. Now, remember, we're already looking up and down by rotating the camera. So all we really want to do is rotate the body to the left and the right. So that's on the y-axis of the body, if I'm not mistaken. So we'll create a new vector3, and we'll take our look.y and multiply that by time.delta time. That should be the x value. Sorry, the look x. We're using the look y to look up and down, and the look. I knew that I had made an unintentional mistake there. But I also made an intentional mistake that I will show you how to fix in just a moment, which is that we are infinitely spinning in a circle. We can move our mouse to the right and we can start spinning, but when we stop, we will infinitely spin, just like we were infinitely moving. We were sliding. This is pretty much the sliding problem. And we can fix it by, once again, just increasing the drag. So 25 is about the sweet spot for me for angular drag. So let's go ahead and play that again. And you will see now we have pretty snappy movement, is that we are actually multiplying that by delta time. That's the reason I had delta time in the code for the camera. And that's the reason. There we go. So we didn't need to do delta time. If you took delta time out of both of those functions, it would be fine. And if you put them in both of them functions, it would be fine. So that's why I had delta time there. Anyway, so now we have pretty smooth movement, pretty snappy movement. My lighting seriously needs to be rebaked, apparently, but that's fine. And you can see that collisions work perfectly. We run into the sphere and we just hit it. We don't have any problems with clipping through things, and we're not like itching forward a little bit. Collisions work fine. We can move around fine. So that's pretty much it. But there is one more thing that I want to show you, is some more processing on the scriptable object here. So let's go over to, let's go over to our input data. You might be tempted to add a multiplier value for your camera and your movement, your body movement scripts. To have a sort of a sensitivity, if you will. But there is one problem with that, is that you're going to have to share that sensitivity value between the two scripts in order to get a consistent sensitivity. You could do that by placing it in the input data. That would work absolutely fine. But another thing you can do is just add a processor. So if we go over to our look value, is that the one? There we go. We can add in a processor. Sorry, that's not the processor that I meant to add. And we can add in a scale vector2 processor. So let's set these both to 10, and this will just scale the vector2 on both values by 10. So it will give us consistent sensitivity settings. So now when I move the mouse, a lot faster. And if I move this up to, say, 40, just to exaggerate the effect, yeah, it's a lot more sensitive now. So that's a great way to control that sensitivity. And basically everything can be accessed through code by simply checking out the look action variables. So this is a pretty good way of reading in your bindings and using them within your code to create controllers. For example, to add a jump, you would just add a jump action, enable and disable, and then subscribe to it in your events. I would recommend using events for things like jumps rather than checking them in update. And what I mean by events is we can literally just call look action.performed. We can add in an event here. So we can plus equals, and then I'll just pass in the value, which is the context. And we'll do debug.log ctx.readValue vector2. Okay, and I'll make sure I got rid of my debug calls there. I did. Okay, and so this will just add an event listener to the look performed and print out the value. So that's another way that you can hook up your events. I did do that in my first InputSystem tutorial. So if you're looking for more information on that, then go ahead and check that out. But you can see in the console now, we're just printing out the value of that. Okay, I think that about covers it. Thank you for watching, and sorry for stumbling a little bit there a couple of times. I can definitely do a tutorial for some more stuff that I may have shown in the intro, like the press E to end level thing. So if you're interested in anything more, second part or anything like that, drop a like, drop a comment, and I'll get onto it. Otherwise, thank you for watching, and have a good day.